So when we think about advertising and market structure, we obviously want to start with perfect competition. And with perfect competition, it doesn't really make sense for firms to advertise because remember, the main assumption with perfect competition is there's lots of firms and they're all selling the exact same product, right? They're selling a homogeneous product. And so unless you're trying to differentiate your product, which is moving us away from perfect competition into something more like monopolistic competition, there's really no reason to advertise from the firm's perspective because it's, if you advertise corn, it's going to help all corn farmers. And so what there is for advertising in perfect competition are often sort of industry-wide advertising. And so often called, generic advertising. So if you think about the, got milk advertising campaign or pork or beef advertising campaigns, they'll be run by a industry group, and they'll be funded by the producers within that industry, but it'll sort of be like a mandatory tax, right? Because you don't want any free riders. So perfect competition, we're generally not expecting to see a lot of advertising. With a monopoly, it's obviously going to depend on the type of monopoly, but we're going to think about we'll think about a monopoly in the sort of profit decision, and the idea is, so we also have to think about sort of static versus dynamic. And so in a static setting, it's going to affect this period's sales, but not next period's. So that might be true for some things like a local sale. But it might not be true for other things. And it's also possible that, if advertising builds up goodwill or product image, brand, that's going to affect future sales as well. So first, we're going to focus on the static effect of advertising. So if we think about the profit decision, we're going to basically assume that we've got a downward sloping demand curve as usual. So demand decreases in price, but it increases in advertising, but only to in a concave sense. So it's going to increase at a decreasing rate. We'll make the price of advertising 1, so that capital A equals total advertising expenditures. And basically what Dorfman and Steiner said was that, all right, we're going to solve this model. And what they found was that the advertising to sales ratio will be higher, obviously, when it's more effective. So that's not that interesting. But also it will be higher as the elasticity of demand falls, so that as firms have more market power, a higher learner index, they will have a higher advertising to sales ratio. And basically that's because you're able to increase your profits more when you have a higher learner index through advertising. So here's one example. So we're going to have profits with 2 firms now, and we want to think about how advertising by firm 1 and firm 2 affect their individual sales, but also overall sales. And so this is an oligopoly type situation, and our profit function here is 100 AI minus AI squared plus B AI AJ. So advertising from the other firm comes into the profit function. And really, it all depends on this parameter B. So we're going to assume that it's greater than -1. But if it's negative, then advertising is combative. So if the other firm advertises, that's going to decrease my profits. But if it's positive, then advertising is constructive. And therefore, advertising from the other firm will increase my profits. And so we're going to look at a couple examples. So obviously, to solve this, we're just going to take the derivative with respect to AI. We get 100 minus 2AI plus BAJ equals 0. And then we can solve that for the 2 best response functions. We'll solve it both in terms of A2 so that we can graph it on the same graph. So we get minus 100 over B plus 2 over B times A1 for the best response function for firm 1. And for the best response function for firm 2, we get A2 equals 50 plus B over 2 A1. And then we can solve for the symmetric equilibrium. So we get AI star equals 100 over 2 minus B, and pi I star equals 10,000 over 2 minus B. Now, so obviously that's going to depend, on B being negative or positive, right? And so we're going to look at 2 examples, one where B equals minus 1/2, so it's combative, and one where it equals positive 1/2, so advertising is constructive. So first, we'll look at the combative case where B equals minus 1/2. And this gives us negative sloped best response functions, right? So 200 minus 4 AI or 50 minus 1/4 A1 for the best response functions. And so this case, we're basically in a prisoner's dilemma in advertising, right? And so both firms are better off advertising less than if they behave independently. And that's because of this negative externality that comes from combative advertising. And so because if they ignore this externality and they don't cooperate, each firm advertises more than if they were to cooperate. So we can kind of see this both in terms of the graph and in terms of, a sort of basic prisoner's dilemma here, where if they advertise 33.3, right, that's in the cartel area, they have higher profits, but the Nash equilibrium is to advertise 40, in which case they end up with profits of only 1,600, right? But if the other one advertises 33.3 and you advertise 40, then you end up with higher profits. And so it's very similar to a prisoner's dilemma. Now, if we look at constructive advertising in an oligopoly, now we have upward sloping best response functions, right? And so in this case, industry profits are higher when advertising expenditures exceed the Nash equilibrium. So here, the Nash equilibrium is to advertise 67. But if we can advertise more, because my advertising helps you and your advertising helps me, we'll actually increase our profits. And so now we might want to actually advertise more if we can come to an agreement, right? But I'm only going to advertise more if you advertise more and vice versa.